Ladies and gentlemen, good afternoon. I'm very delighted to introduce NAAREA to you. It's a French company that we started 4 years ago, but it all started 40 years ago. When I started my career, I was a young boy at 14 years old working in the construction of submarines. So I was a worker on the deep milling machines and machining. And it all started with something that we call today sustainable development. So during my career, I've been expatriated everywhere in the world, trying to electrify because I was working in railways and then in the water business. And the problem was always the same. How can I power the plants, the system I was building on the sustainable side without polluting the planet? And we were already seeing the first problems of the climate change and having more and more waste. And then it all started again in 2015, COP21 in Paris. I was at that time at the head of De Gremont, the leader in water treatment in the world, and we've been working on the sustainable goals, the development goals, with the COP21. And I asked all my teams in the world, I had a huge team of 8,000 people roughly, and I asked them, can you help me in answering this question? How can we boost the achievement of those 17 SDGs? Because everybody was very happy. It was the Paris Agreement that we signed here. It was 193 countries. Wow, wonderful. But how can we make it? A lot of people were saying at that time, we will never make it. It's a pure communication goal. And actually, we made this study. And the result, the output of this study is that there is one universal lever for the 17 sustainable goals. It's energy. And there is not a second one, there is only one. So we said that's a vision that we can build on the table because we have something. If we play on the energy side, then we have an impact immediately on the 17 Sustainable Development Goals. So then we looked at it deeply and we realized that in fact the energy production is responsible for more than 70% of the CO2 emissions. Then it all started saying that, okay, so we will need energy anyway, we will need clean energy, but then we need to be able to produce this in abundance. And then we had to look at the quantity of energy that we will need by 2050. And this we've been amazed, because it all started from 2020. We have the population that will grow on the planet up to 10 billion, and then there is this digital growth, because there is an hypergrowth on the digital. And then we have this energy transition. And if we take only 75 of the energy transition, we realize that the projection of the energy demand will be from 30 petawatt-hour to 100 petawatt-hour in 30 years. How can we make it? How can we do it in 30 years? Because on the other side of the production, of the offer, we have, of course, the equilibrium in 2020, but then we know that we will have a reduction in fossil fuel, and then if we take an optimistic solution saying that we will multiply, let's be crazy, by 10 all renewables plants in the world, we are still missing 2/3 of the demand. So that's a major problem. Then we had a look at the Energy Council, the World Energy Council. They talked about the energy trilemma. What does that mean? It means that if you want to make a roadmap for the energy of the future, you need to answer 3 main criteria. First, it has to be secured and safe. Second, it has to be sustainable. And third, it has to be equitable, meaning accessible and cheap. That's the main problem. There is no technology on the planet today able to fulfill those 3 challenges and to be scalable on a large scale. That's the starting point of NAAREA. We said if it does not exist, it is the starting point of what we want to produce. So we decided to build a carbon-free power supply, to be clean and circular, nearby, meaning decentralized energy, not anymore massified, safe and secure, non-intermittent, of course, to be able to compensate the intermittence of the renewables, affordable and competitive, and now, not in 100th century, but now, tomorrow. That's NAAREA. So we had to decide on 3 missions, 2 main missions. We said we will innovate, we will recycle, and we will decarbonate. The first thing is that we want to innovate. What does that mean? NAAREA wants to create IP. IP is not something easy to do. It means this is pure science, and this is technology. It's the know-how we want to develop on nuclear side and on the non-nuclear side, because everything is combined. Second, we decided to go for the fast neutron facility. So what is fast neutrons? Fast neutrons allows you to burn nuclear waste. And of course, we decided on the innovation to develop some labs, and a lot of different labs. We have already one with the CNRS in Orsay today on molten salt, but we want to have more facilities and more labs. Then on the recycle side, we decided to make waste-to-energy nuclear. It already exists. Only 2 countries in the world are able to manage this technology, France and Russia. The Americans, they don't know how to do it. The Chinese, they don't know how to do it. They've never done this before. They are looking at it, they are studying it, but they didn't build real plant. We did. It was Super Phoenix, and it should have been Astrid in France. And in Russia, they have 2 facilities running every day. And third one, we decided to decarbonate the world, meaning we want to offer as a service, and you will see how we will do it on the business model after, heat, high temperature heat, and electricity. Why heat? Because 70 to 80% of the energy consumed in industry in the world is heat. It is not electricity. So it's an easy way, it's an easy path to say that we need to electrify the usage, but sometimes you don't have the capex to be able to electrify your own process. Whereas if you have the heat, carbon-free heat, you immediately decarbonate your own process. And of course, we decided also to play on the carbon credit because we have a lot of different ways to do it. So what is the value proposition of NAAREA? We have 3 unique strategic features. The first one is on the technology side. Then we combine this with the industrialization and then the business model. It is also unique in nuclear because private companies in nuclear is something new, but private company able to make business model and a real business as a service is something totally outstanding. So first, on the technology side, we decided to decentralize, meaning that we had to create a very small reactor, what we call a micro-sized reactor, 40 to 80 megawatt thermal. Then we decided to choose the fourth generation of nuclear called molten salt reactor. Why? Because it has an inherent safety profile which is absolutely above the existing one, which is already very safe. Pressurized water reactors are very safe, but the molten salt is far above. And then we decided the fast neutron, as I said, because we wanted to create waste to energy. So our fuel is nuclear waste, the long-lasting nuclear waste created by the conventional pressurized water reactors. We separate them, we transfer them, and then we make our own fuel. And of course, we demonstrate that there is no long-lasting waste at the end of the day. On the industrialization side, we decided to make a product, not anymore a project. We are not making infrastructure, we are producing superstructure, totally different. The difference is that you create everything and you build everything in a factory, in a plant. There is very light civil work on your concrete slab on which you will put the reactor, but everything is made in a plant. It changes everything because then you increase the quantity, you increase the cost competitiveness, and you increase the reliability. When you build a project on site, the non-quality, whatever you will do, will never be below 3 to 5%. If you are in a plant, you divide this by 100. So you see the advantage of building everything in a plant. And then on the business model, we decided to deliver the energy as a service, meaning that we do not sell the technology. We provide the heat and the electricity directly to the customers, and the customers are industrial plants. And of course, it helps having the full sovereignty on the fuel cycle. So how do we synthesize this? First, you have the picture of this reactor. It's very small. It's like an autobus. An autobus which is a 40-foot container. This is the nuclear island. The core of the nuclear reactor is big like a washing machine. So it fits here on stage with me. And everything which is around it is only the technology just to control the irradiation. But you see, it's quite simple. The biggest novelty that we have, and it's thanks to science once again, is that we created a heat exchanger inside the nuclear core, which had never been done before. This is the novelty of NAAREA. So we combine, as I said, the nuclear technology with the recycling of the nuclear spent fuel from the conventional nuclear plants, 80 megawatt thermal or 40 megawatt electrical. 40 megawatt is the power of a city of 200,000 people, you see, in the average. And then it fits, as you see, in a 40-foot container. Second, we combine this with the industrialization. And of course, we will be close to industrial plants. So you see it's quite small, 100 meters per 100 meters, and you have everything on site, all the security you can imagine, and it's absolutely safe. And then we combine this with the, as I said, the business model with a long-term service business model, meaning we have only contracts above 15 years, 20 years, 25 years, and we deliver this energy. So it's electricity, high temperature heat, and fatal heat, because when you convert high temperature heat to electricity, you also produce the same amount of fatal heat. Heat, you cannot transport it. So when you are on the premises of the industrial customer, you can immediately value your heat. So at the end of the day, the efficiency of your energy plant is 95% and not 30% as every energy plant in the world. And so let's have a look at what SpaceX did. This is pure evolution of science and technology. This is the same reactor from 2019 to 2024. What's the difference? It's obvious. We did exactly the same with nuclear. On the left side, we decided to use what we call the cross-fertilization. We went to each and every sector where they have made a lot of innovation, and we tried to translate the innovation we've seen on our technology. And guess we have simplified a lot. This is why we are able today to integrate everything in a single container. Of course, it is not SpaceX, but I think you can be proud of it, because look at the simplicity of such a reactor. It's very simple. You do everything without, except the transformation of the heat into electricity, which is done in a second container. But as a whole, everything in a nutshell, you save the weight, you save money, and you save time, because the time schedule to produce such a reactor is only 1 month. So you can imagine 40 megawatts you produce in a plant, you will be able to produce 50 up to 100 reactors in a plant per year, which means the equivalent of an EPR every year, only for one line. And of course, we have a huge factory being studied today with 10 different lines. So I let you make the math. You see that it's a wonderful way with pure science to be able to deploy the nuclear on a safety, very safe approach on a very, very, very large scale. So that's the idea of NAAREA, and we believe that with this deployment that will occur by 2030, we will be able to reconcile the human activity with the sustainability of the planet. And as it's an election time right now, we love this tagline, but we can make our planet great again. Thank you very much.
Thank you so much. This is energizing, I think. Yes, that was easy. I have a question. It's time for question. And it's back to the energy need. I don't know if you noticed a couple of weeks ago, I think 2 weeks ago, Microsoft had a huge PR with a 3 Mile Island, famous plant, nuclear plant. And lots of people are saying that with the AI consumption, even though AI is trying to diminish this, there is a new connection with the nuclear industry. What's your take on this?
We have made a lot of different calculations. We started 4 years ago saying that AI would be at the same amount. The energy demand from AI would be above the energy demand of the whole of the rest of the economy. And today, it's confirming that. If you take a data center or AI center, it's in the range between 50 megawatt to 300 megawatt. How we will be able to produce that? If it takes us 15 years to build an EPR, it will be complicated. And above all, it's not only building energy production facility. How can you transport the electricity to the data center? You need the grid. The grid costs more money than building the power plant. So when you decentralize, you give the answer. So we are very happy to see our American friends going very, very hard on the SMR and on the AMR and on 3 Mile Islands that will be recovered. But we believe that our solution is quite sexy.
I guess so. Any other questions? Many over there.
Decentralizing nuclear energy is a bright idea, but there is an issue, which is that of how do you manage the terrorist risk with so many small plants?
Sure. When we say safe and secure, we have the same requirements as a conventional nuclear plants, and we demonstrate that we have the same resistance. I cannot explain you how, because it's secret, but you need to demonstrate to the Nuclear Safety Authority and to the Nuclear Security Authority, which are different in France, that you withstand any threat of, there is a referential, which is secret, but this referential is quite hard, and you need to demonstrate that you have put everything and that nothing will happen. The good point with that technology is that it's a molten salt. It means that it's pure chemical and it's liquid. That's the huge difference with the conventional nuclear. Nuclear is in solid fission today in every plant in the world. We are in a liquid mode. But the liquid mode means that the atoms of every radioactive elements, they are in the liquid. If they are at the temperature of 700 degrees inside the reactor. If for any chance it touches the air, immediately it will crystallize and drop on the ground. So you have no chance of having a cloud of radioactive material. That's one point. There are plenty of other plants, such as, for example, it's a liquid. So when you have a problem, you just flush. That's a fantastic facility. Because sometimes you see the threat, especially with all the equipment on the digital world we have today, we are able to anticipate or to see, to forecast the threat. If you see any threat, you just flush the reactor. We have reservoirs and tanks below the reactor, which are absolutely in a safe mode and very strong, and then it will not be possible to hit the liquid inside. So plenty of different things which show that first you comply with any requirements from the government, but second, after the threat, you recover the operation.
There was another one. Or not the lady.
What about recycling? Because it's not the same thing if we have one nuclear plant somewhere that you encapsulate, and if you have all these mini reactors everywhere. And what is the reversibility finally of this installation? You flush it, okay.
The reversibility is fantastic because if you want to just move the reactor, you just move it. It's not a power plant that you cannot move anymore. Okay.
And about recycling?
And everything is designed to be fully recycled. Any component inside is fully recycled. Yep.
Okay.
I'm not talking only about the fuel, but about any component of the reactor.
Great. Thank you.
Final one.
I hope this is not a stupid question, but as a nuclear entrepreneur, why did you choose nuclear fission and not nuclear fusion?
Very good question. I asked myself 4 years ago which one I would choose. Fission, I believe fission is fantastic. That's the future, but I will probably not see it. It's for 2070, 2080, the commercial deployment. Of course, there will be fantastic discoveries before, but on the commercial side, it's quite complex. How do we do between today and 2070? The only solution I've taken is fission, because it's the only way we have on the table today on a manageable future.